Welcome back to Differential Calculus class. We are still on rules of differentiation. So in this class, I'll be teaching you product rule of differentiation. So let's start. So given f of x, this function equals, let's say g, we have a function that depends on x, then multiplied by another function that depends on x. Okay. So this function is equivalent to this. In some textbook it is written as this. We have u, okay? Don't get confused. So it's the same thing. Don't get confused. It's the same thing. Okay, so it's a matter of letters. So this matter of letters is a matter of choice. So have G, we use G and H here. Here we use U and V here. So don't get confused. So it's still the same thing. Okay, so here U is equivalent to G, while V is equivalent to H here. Okay, but let's continue with this G and H. Let's say we have this function. So differential rule states that if we have this function, that the differential of this is equivalent to, we take this, we hold this constant, that is G, X, then multiply by the differential of the second function. That we hold the first constant, then we differentiate the second one. That is, we are going to differentiate this. Okay, then plus, we hold this constant this time around, h, x, then we differentiate this first one, multiply by g, x. So this is equivalent to, if we have used u and v, it will be equivalent to saying we have u of x, then we differentiate this, plus v of x, then we differentiate this. So it's equivalent to this. Okay? It's equivalent to this. That is, if we have used u and v. Okay? So the essence of writing is so that you don't get confused when you find this in some textbook you use. Okay, so these are equivalent. Anyway, so that is the product rule. Okay, now let's take a look at some examples. So let's maintain this first. Now, let's say we have this example. Let's say we have I have to find the derivative of, let's say we have f of x. Okay, don't let me use f of x this time around. Let me make it. So y equals, let's say we have 2x squared. 2x squared, then we have in brackets. To find the derivative, here is the solution. Don't forget the product rule that says that this is it, actually. But this same rule can be rewritten as this. So remember we have y equals 2x squared. Then we have 2x minus 5. Okay. So the rule says that the y, the x is equivalent to f or f prime of x. Okay, but because we are given y here, so we want to maintain that. So it's equal to the first function. Don't forget that the first function here we hold it constant. Okay, we say g of x. Then we differentiate the second one, h. Then we have x. Okay, then we say plus. The second one we hold it constant. Then we differentiate the first one. This. So this is equivalent to saying v u of x. Then we differentiate this. then plus v of x, then we differentiate the first one. So equivalent. So it's also equivalent to this. If I want to remove this, so I can just say u dv dx. Then I said plus v du dx. So all these are equivalent. This equivalent to this, okay, and you know this equivalent to this. Okay, but this is the most common one in textbook. So we are going to apply this. So whatever the one we apply, we are going to get the same thing. So now let me clean this. Let me clean this. So here, if we apply this, you can see here, if we assume this is u, let me write that. That's y equals 2x squared 2x minus 5. So this first one is my u, while this second one here is my v. Okay, this is my v. U, and I think my u is already known, which is 2x squared. Okay, is it 2x squared? Yes. Then I know my v to be equal to 2x minus 5. But I need to derive my du dx and dv dx. So in other words, my du dx, which is equivalent to simply this dimension of u with respect to x, is equal to this. I want to differentiate this. So if I multiply these two, that will be 2 times 2, that is 4. I have 4x. Okay. Likewise, I have my dv dx, which is equivalent to just this. It's what we differentiate with respect to x. Mind you, this is a linear function. So you remember the rule when you have a linear function differentiate. So the derivative is going to be the coefficient of the variable there. So this is the coefficient which is 2. Then we are good to go. We can now derive our dy dx, which is equal to, let me write that, u dv over dx. Then we have plus v du over dx. So I will still clean this. Now let me substitute. I will just replace what is my u. U is simply 2x squared, then multiply by dv du. What's dv du? Is simply 2. Then plus, what is our v? V in this y is simply 2x minus 5. Then what is du dx? Our du dx is simply 4x. 4x. Okay? Simply 4x. Now, we can open the bracket. We have 2 times 2x squared. We have 4x squared. Then plus, we can open the bracket here. 4x times 2x. That will give us 8x squared. Then minus, so 4x times 5, that will give us, because this is minus times plus, yes, that's why we have minus. 4x times 5 here gives us 20x. Okay? So, do you have any common factors? Yes, we do. So, what do we have? We add this together, we have 12x squared. Okay, I have 12x squared, then minus 20x. Minus 20x. I think this is the final answer. Okay. Now, let me give you this. Can you try this? Try. Try this. Divide the x. So, do that and drop your answer in the comment section.